In this class, we're going to consider how you solve polynomial equations. So a polynomial equation is generally just a polynomial expression set equal to 0. So like this guy here, this is a cubic type of polynomial. So we've taken that polynomial expression, set it equal to 0, and that becomes a polynomial equation. But sometimes they're not quite in that format. Sometimes like a couple of the terms might be over here, so it's not equal to 0. So you've got to reform it into this, but this is a format we want it to be in. So polynomial equal to 0. Just to backtrack from that a little, when you first see polynomial equations, it's with quadratics usually, and we generally don't even refer to them as polynomials at that point. We just say this is a quadratic equation, but a quadratic is essentially a type of polynomial. So maybe already you've seen things like x squared plus 6x plus 8 equals 0. So it'll be a quadratic equation, but it is essentially a watered down version of this guy here. This one we would solve by factorising. So if you're familiar with this, then it will look like a process that you've practiced before, just putting that into two brackets. So it would be a 4 and a 2 and two positives in this case. If you've never seen this before, don't worry about it. We're going to look at something slightly different with this anyway. This is just really an introduction to how we solve polynomial equations. We're just using this as kind of a starting point. So the way that this one works, once you've got it factorized, then we essentially split the two brackets off into two separate equations just by setting the bracket equal to 0. So we're going to have for the first bracket x plus 4 equals 0, and for the second bracket x plus 2 equals 0. And then we just have these fairly trivial linear equations to solve. So we get x equals minus 4, that's the first solution to the equation, and then we get x equals minus 2 from the second factor, that's the second solution to the equation. And that's basically two solutions because we had a quadratic equation. So the power, the highest power that goes with your polynomial dictates the maximum number of solutions you can have. So that's kind of how we would go through that flow, and the fact that we got two solutions is consistent with what we might expect. You don't have to get two for a quadratic, you could get one solution, and some quadratic equations don't have any solutions, so 2 is certainly the maximum number that we can have. Similarly, for a power of 3, which is a cubic, we can only have 3 solutions maximum. For a power of 4, which is a quartic, we can only have 4, and it carries on like that. So the highest power, which we call the order of the polynomial, dictates the most solutions that we can get for the equation. But in general, you have a polynomial equal to 0, and we're going to solve that by factorising. So let's say that we did have a quartic, which would be a power of 4. So that's going to be a polynomial that contains a power of 4 term. Well, a quartic set equal to 0 and then factorised should end up with 4 brackets. So 1, 2, 3, 4 to go with the highest power, or the type, the quartic type of polynomial. And then once we get to that point, we would just do the same thing we did here, split it off, but this time we'd be splitting off into 4 mini equations and getting our 4 solutions. Or it could be that one of these brackets would be the same, and that's called a repeated factor. Sorry, 2 of the brackets would be the same, so x plus 1, x plus 1. In that case, we can still get 2 little equations, but we only get one unique solution from those 2. So it would be one solution from these, and then another, and then potentially another solution there if these guys were different. So something like that, for example. So that would give you 3 solutions, or it could be that, you know, this was a 7, and then you would get 4 solutions. But the important point is that we've gotten to that solutions, we've gotten to the point of being able to get the solutions by factorising the original quartic, whatever it was, into these brackets here. So that's essentially how you solve polynomial equations, whether they're quadratics or cubics or quartics. We have some means of factorising, and then from those factors, we make little mini equations and then just solve them. The last part is always really easy. It's the factorising that is the key. That is the difficult part. So in this class, we're not going to talk about factorising. In fact, in the previous class, I showed you how to factorise a cubic polynomial using synthetic division. And that would also work on a quartic, although sometimes you've got to do the process twice. So you should already be familiar with how to factorise this. I just want to then move that forward to thinking about how we solve it. So in that class, we did the synthetic division table. If you're not sure about that, then definitely check out that class first and then come back into this one. And when we went through the process of factorising, so let's just say that we skipped a few lines of working in there and we got this thing factorised. The way that this one came out, this one was quite unusual actually. It came out as x minus 2 and then a second factor of x squared minus 1. And keeping that in an equation, that would be still equal to 0. So that guy there is just the same as that guy there, and this is just part of the factorised form. But it goes a little further, that one, because the x squared minus 1 is a difference of two squares, and that can be factorised into two brackets. So if we fully factorise it, we would get x minus 2 and then x minus 1, x plus 1. That's just how we factorise a difference of squares like that. So at this point, we're looking good, right? Because we started off with a cubic, a power of 3. We factorised it. We've got 3 unique brackets, which is going to give us then 3 unique solutions. So all we do at this point is just split these off into their 3 equations. I don't know why I'm writing that in red. It just kind of emphasises the need to make 3 little equations, I guess. So making this guy x minus 2 equals 0, and then x minus 1 equals 0. And that's just how we go about solving these. X plus 1 also equals 0. And then just solving those to get a first solution of 2, a second solution of 1, and a third solution of minus 1. So all of these 3 solutions would independently satisfy that original equation. And that's essentially how you solve polynomial equations. Powers of 3 tend to be where you start polynomial equations, and maybe that's all you'll ever see because they're a really nice power, a nice order to work with. When you get up to powers of 4, they get more difficult. Anything beyond that is significantly more challenging. The great thing about these guys is we can factorize it to this point using the synthetic division technique. And synthetic division is not easy. It's a technique to learn in itself, and you should check that out again in the other class, but it's a level above this here. So this here we can just factorize. If you've done enough of these and you've practiced these, we can factorize them fairly quickly. I mean, literally in like 10 seconds. This takes a little bit more work, so there's a bit more involved when you move up to a power of 3, a cubic, but it's not overly elaborate like a quartic starts to get quite difficult to factorize. So the main takeaway from this class is that you solve polynomial equations by factorising, where they do factorise. Some of them won't always factorise. But if they do factorise, which they will if they've been given to you as a question to do, then the key is how do I factorise? And one of the techniques is synthetic division. There's other techniques as well. There's also a bit of nuance within synthetic division because sometimes we're told one of the factors, sometimes we're not told the factors, sometimes they factorise with a difference of squares, sometimes with a trinomial. So there's a bit of variety and things to get used to. But the absolute key is to get from here to this intermediate point of factorising. Once you get to there, solving them is fairly trivial. And know as well that whatever the order is, that is the maximum number of solutions you should expect. And generally in these questions, the number of solutions will match the order because that's how the questions are usually designed. Not always. You might find some cubics where you only get 1 solution or 2 solutions, but in general, if you're working a polynomial topic, you're going to get 3 solutions. The thing that is a follow-on from that is how this here connects with the graph of a polynomial function. So this cubic function generally makes a graph that shapes something like that. One of the things you want to explore in the polynomial topic is how do these numbers and how does this factorization and the original algebra all connect in with the graph? That's not something we explore here, but we do look at that in the course. And actually knowing the graphs, understanding how the graphs work, can give you some good information backwards to the algebra. So the algebra informs the graph informs the algebra, and eventually that's where you want to get to with polynomials. And polynomials are one of the big types, categories, families, if you like, of functions, which are really important for pre-calculus and then moving into calculus in the future. So that's basically how you go about solving a polynomial equation.